Hello dear, in this session we are discussing some inorganic chemistry reactions like hydrolysis of inorganic compounds. There are various reactions in various chapters. We are concluded at one place so that reaction will be memorized in an easy manner. First, hydrolysis of oxide. It's an ionic compound. Like Na2O react with water. Whenever ionic compound is given, you have to assume water is H plus and OH minus. ये H2O it treat as a H plus and OH minus. You are getting NaOH. They are the two sodium, two oxygen, two hydrogen, balanced reaction. That is the reason oxide of metals are basic in nature because they are giving base on hydrolysis. I am giving you another example. Magnesium oxides plus H2O की reaction hydrolysis होगा. Again it's an ionic compound my dear. Water are treated as a H plus and OH minus. Magnesium is +2, oxygen is -2. Ion exchange reaction and we will get my dear magnesium hydroxide. One magnesium, two oxygen and two hydrogen. Reaction is balanced. Another example is calcium oxide plus H2O. Water is just as a spray. We are getting the calcium hydroxide. This is called slaked lime. Again, we are adding the water, my dear. The formula are same. Calcium hydroxide. This is called milk of lime. If we are adding the another water, the formula is same. Calcium hydroxide, but we are getting the clear solution. That milk of lime is white turbidity. White turbidity, and this is the lime water, clear solution. These chemical reactions are come from the S block, sodium, magnesium and calcium hydroxides. So various reactions are given. We are adding all the reactions at one place. Again, second reaction is hydrolysis of nitrite. ये भी it's a ionic compound. And what is nitrite, my dear? N3 minus. It's a nitrite. Giving you example, aluminium nitride. If any aluminium nitride react with water, gives ammonia gas plus base, aluminium hydroxide plus base, ammonia is a base. In combined state, aluminium always shows +3 oxidation states. It's a plus, it's a minus. In case of ionic compound, water are treated as a H plus and OH minus. Again, ion exchange reaction. Aluminium 1, nitrogen 1, balanced है. There are the 6 hydrogen, my dear. Okay, and so we are adding the 3H2, reaction balanced. Again, one more example. Magnesium nitride, Mg3N2 plus water, ionic compound, my dear. We are getting the magnesium hydroxide plus ammonia, Mg plus and minus water are treated as a H plus and OH minus ion exchange reaction. 3 magnesium, we are adding the 3 magnesium, 2 nitrogen, 2 nitrogen. How many hydrogen, my dear? There are the 6 and 6, 12 hydrogen. So we are adding the 6. Reaction is balanced. Another example, my dear. Third, hydrolysis of phosphide. It is also ionic compound. Phosphide, aluminium phosphide plus H2O की reaction. We are getting the aluminium hydroxide plus phosphine gas. Phosphine is more poisonous than ammonia. One aluminium, one phosphorus. How many hydrogen, my dear? Here there are the 6 hydrogen. So we are adding the 3. One more example, calcium phosphide, Ca3P2. Phosphide, what is phosphide, my dear? P3 minus. P3 minus. React with water, giving calcium hydroxide plus phosphine gas. How many calcium? 3. How many phosphorus? 2. How many hydrogen? 6 and 6, 12 hydrogen. So we are adding the 6. Fourth, hydrolysis of hydrides. Hydrolysis of hydride. I am giving example, sodium hydride. Hydride is also ionic compound. Sodium hydride plus water. Water are treated as a H plus and OH minus ion exchange reaction. We are getting the NaOH plus H2. Vishesh, it's an important point, my dear. Na plus and H minus. H minus H plus release the hydrogen gas. Okay. How many sodium, my dear? 1. How many hydrogen, my dear? 3. How many oxygen? 1. Reaction balance. This is the one more minus and hydrogen plus. This is called H2. Here, oxidation of hydrogen is 0. Oxidation number of hydrogen is 0. Again, my dear, hydrolyth. Plus water gives calcium hydroxide plus hydrogen. 1 calcium, 4 hydrogen, and there are 2 oxygen. And here we are getting the 1 oxygen. So we should multiply the 2. How many hydrogen? 4 or 2, 6. How many hydrogen? 2. You should multiply the 2. So we are getting the hydrogen. The question comes from which type of gases are released. And you can say question can be asked from their atomicity also. What is the atomicity of phosphine? 4. What is the atomicity of hydrogen? 2. And the characteristics of the gas, like phosphine is a poisonous gas. Yes. Hydrogen is combustion gas. It is combustible gas. Yes. So these type of questions comes. Fifth, hydrolysis of carbide. It is also ionic compound. Calcium carbides. CaC2 plus H2O, beryllium carbide Be2C, aluminum carbide Al4C3, magnesium carbide Mg2C3. Calcium is +2, carbon has 2 carbon has -2 oxidation states, and in case of ionic compound we are adding the ion exchange reaction. Water are treated as a H plus and OH minus. So definitely, my dear, C2H2 gas plus calcium hydroxide. Metal will always give hydroxide. It's a base. How many hydrogen, my dear? 4 hydrogen. You should multiply the 2. Reaction balanced. Beryllium, 1 beryllium is +2, 2 beryllium is +4. Carbon is -4. Water should be considered in case of ionic compound H plus and OH minus. It's a trick to do the question. 4 minus, we are adding the 4H plus. So we are getting the CH4 gas plus beryllium hydroxide. How many beryllium? 2. 2 beryllium. How many hydrogen, my dear? Here 2. Here 4 or 4, 8 hydrogen, my dear. So definitely you should multiply the 4. Reaction balanced. Aluminium, 1 aluminium is +3. 4 aluminium is +12. -12. That is the 1 carbon having the -4. We are getting the, my dear, again CH4, methane, marsh gas, and aluminium hydroxide. How many aluminium? 4. So either 4. How many carbon? 3. 3. How many hydrogen, my dear? 12 or 12. 24. You should add that 12H2O. I hope reaction balanced, my dear. That 12 oxygen. Here 12 oxygen. Reaction balanced. The thing is important. CH4, the name is methane. Can be asked. Marsh gas. Atomicity 5. So questions come from the significance of and the properties of CH4. CH4 can be directly asked or indirectly asked in examination like JEE and NEET. Water, magnesium carbide, definitely, my dear, 1 magnesium +2, 2 magnesium +4, and -4, C3, 4 minus. So you are adding the 4H, that is C3H4 plus magnesium hydroxide, 2 magnesium, 2 magnesium, 3 carbon, 3 carbon. How many hydrogen, my dear? 2, 4 or 4, 8. So you should add the 4. I hope clear. C3H4, what is C3H4? Propine. This is propine. Question can be asked, how many DBE, double bond equivalent, degree of unsaturation, and IHD, released gas? My dear, the answer is 2. Question can be asked in the hybridization, sigma bond and pi bond. Question can be asked. Now next, my dear, 6th point, hydrolysis of halides. First, BF3 plus H2O. Fluorine is replaced by OH. Now we are getting, my dear, BOH whole 3 plus 3HF. It looks like base, but it is not a base. It's an acid. It's a boric acid. H3BO3. Boric acid. You have to remember and memorize all the properties of the boric acid. Now again, BF3 plus HF react and gives HBF4 or BF4 minus what we are getting 3HF, 3BF3 and balanced reaction. Okay, if you are adding both reaction 3HF cross my dear H2O भी कितने आएंगे 3 आएंगे. Now 4BF3 react with 3 moles of water gives thrice HBF4 plus boric acid H3BO3. It's a partial hydrolysis of BF3. BF3 gives partial hydrolysis. Question comes, not complete hydrolysis. Not complete hydrolysis. That is the important. Out of 4 mole of BF3, देखिए, I am giving you another. Out of 4 mole of BF3, 1 mole of BF3 hydrolyzed and 3 mole of BF3 forms the complex compound. Out of 4 mole of BF3, 1 mole of BF3 hydrolyzed. Hydrolysis. That is the important. Another BCl4 minus BBr4 minus BI4 minus do not exist. Do not exist due to steric crowding. These are the very important questions. They BCl3, BBr3, BI3 are completely hydrolyzed because they do not form the complex compound due to steric crowding. Second, SiF4 plus H2O. Halogen are replaced by OH, silicic acid plus 4HF. Then again SiF4 react with HF of 2 mole of 2 mole. We are getting the H2SiF6 or SiF6 2 minus. If we multiply by the 2, here 4 and here 2, because in first 2 mole react. Now overall 4 mole react. If we are adding 3 mole of SiF4 react with H2O gives SiOH whole 4 plus 2 mole of H2SiF6. So my dear, 3 mole of SiF4, 1 mole of SiF4 is hydrolyzed. The another thing is partial hydrolysis. Partial hydrolysis. Partial hydrolysis. Why? 3 mole of SiF4, 1 mole is hydrolysis. That is the important thing. Another one more question comes from SiCl6 2 minus, SiBr6 2 minus, SiI6 2 minus do not exist due to steric crowding. So we are watching the some example of S block, some example of boron family, some example of silicon family. The all hydrolysis are given in your NCRT and your NEET examination, JEE examination, but they are in different chapters. We are adding out at a one place, so reaction will be memorized easy. Third, NCl3, nitrogen family, PCl3, nitrogen phosphorus, arsenic, antimony और bismuth. वाटर के साथ रिएक्शन है. My dear, center atom nitrogen do not have vacant orbital, so lone pair of oxygen will attack to the surrounding atom like chlorine. So my dear, we are getting the HOCl, 3 mole of HOCl plus 3 mole of ammonia gas. Why? Because center atom nitrogen do not have vacant orbital. That's why lone pair of oxygen will attack to the surrounding atom of NCl3 like chlorine. Again, my dear, react with H2O. How many mole? 3 mole. PCl3. Now, my dear, they are the +3 oxidation state. This is odd number and group number 15. That is odd oxidation state, odd group number. The same oxidation state product will be formed. We are getting the H3PO3 plus 3 mole of HCl, 6 hydrogen, 6 hydrogen, 3 oxygen, 3 oxygen, reaction balanced. The same, my dear. What is the difference, my dear? Here, lone pair of oxygen will attack to the vacant orbital of phosphorus. That is the basic difference, my dear. Here, H3, ASO3 plus 3 HCl, same product. Odd oxidation state, odd group number, same oxidation state product will be formed. SbCl3 and BiCl3. These are again the example of partial hydrolysis. In general, these 4 partial hydrolysis are very, very important. So many times comes in our previous JEE and NEET examination. Here, SbOCl, antimony, oxychloride is a white turbidity. White turbidity plus 3 mole of HCl. is proper balance. We are not doing the balance the reaction because the thing is important. Here BiOCl, my dear, plus HCl. Here again bismuth, oxychloride, white turbidity. These are the important. So here we are watching the so many types of hydrolysis of halides 1, 2, and 3. Fourth, one more example, beta. Inert gases. XeF2 hydrolyzed करेंगे, hydrolyzed, replace and getting OH. Xenon hydroxide plus 2 mole of HF. Here 2H2O. It's a highly unstable. Dissociate into xenon plus half oxygen plus H2O. If you are adding the full reaction, my dear, XeF2 react with twice H2O gives xenon plus half oxygen plus H2O plus 2HF. Xenon here plus 2 oxidation state, here 0. That is reduction. Oxygen minus 2, here 0. That is oxidation. You can say it's a redox reaction. The question comes, my dear, it's a redox reaction. Another example, my dear, XeF4 and XeF6. XeF4 and XeF6. Here, xenon has plus 4 oxidation state. Here, xenon has plus 6 oxidation states. Hydrolyzed 2 fluorine are replaced by 1 oxygen. 6 fluorine are replaced by 3 oxygen. My dear, we are getting the XeO3 plus 3 mole of HF. So, how many water will be used, my dear? There are the 3. 6. So, here, my dear, 6 HF will be formed. XeO3 is the colorless explosive solid. Important. Colorless explosive solid. And what is the structure of XeO3? This is also important. Questions comes direct and indirect. These are the important things. Question can be asked, what is the bond order of the product? What is the hybridization of the product? How many sigma bond, pi bond of the products? Now, another question is, my dear, XeF6 plus 1 mole of H2O. We are discussing the mechanism. 2 fluorine are replaced by 1 oxygen, XeOF2, XeOF4 plus 2HF. Now again, XeOF4 plus H2O, again 2 fluorine are replaced by 1 oxygen. We are getting the XeO2F2 plus 2HF. Again, my dear, XeO2F2 plus H2O gives XeO3 plus 2HF. Now, this is the main reaction. This is the main reaction, and this is the mechanism. Plus 6, plus 6, plus 6. That is, xenon do not change their oxidation number. Is that clear? Xenon do not change their oxidation number. Oxidation state of xenon are remain same, and these are the intermediate. Question can be asked in any way. Intermediate. Now, one trick is involved. We are getting the product from the XeF2 and XeF6. What is the oxidation state in XeF2? Plus 2, XeF6 plus 6, and XeF4 plus 4. So, average oxidation state we are getting. So, we are getting the average product. That is the trick, my dear. Xenon plus half oxygen plus HF plus XeO3. I hope so. Trick you have to memorize. Plus 2 plus 6, average plus 4. The product will be average. I hope so. The concept is clear. Reaction balance, that is a different thing. Lecture is lengthy. I don't want to, the lecture is to become lengthy. It should be short because it's a demo lecture. Now the last example, my dear, hydrolysis. Hydrolysis of P block oxides. They are the concept. Odd group number, odd oxidation state, odd product. We are getting the odd group number, odd oxidation state, same oxidation state, product form. Even group number, even oxidation state, same oxidation state, product form. It's a general statement. In case 99% the statement is right. Exception is everywhere, my dear. If odd group number, even oxidation state, disproportionation. These are the basic trick to memorized. I am giving you some example like N plus 3 hydrolyzed. What we are getting, my dear? HNO2. N plus 5 plus H2O. What we are getting, my dear? HNO3. N plus 4 H2O. What we are getting, my dear? HNO2 plus HNO3. Remember, odd oxidation state, odd group number. Same oxidation state product will be formed. Odd oxidation state, odd group number, same oxidation state product will be formed. Or even oxidation state, odd group number, disproportionation, that is plus 3 and plus 5. Oxide can be any, my dear. Here you can write N2O3 plus 3A, N2O5 plus 5A, and NO2 plus 4A. So these are there are so many tricks. There are so many tricks. One more tricks, my dear. Chlorine है halogen family, Cl plus H2O. Now, my dear, what is HOCl? Why? 17 group odd plus odd, group number odd, oxidation state odd. That's we are getting the same oxidation state product form. Another example, my dear, Cl 3 plus, odd oxidation state, odd group number. Now we are getting the, my dear, HClO2. Here Cl2O, the example. Here Cl2O3, here is the example. So there are so many concepts. I can't deliver all the hydrolysis in a very small time, but we will meet later. Thank you.